No, it's really good though. It never ceases to amaze me, the enthusiasm, the community around Python. And I hope today to kind of talk a little about the communities I've been a part of and some of the experiences I've had, and hopefully give you some things to share about. I've been doing this a long time, it's very true. Some of what I've done has been useful, some has been distracting, some has been probably downright annoying to some. But I've been really passionate about what I've been doing for a long, long time. It started with science. We'll talk a little bit about that before. In 2012, had a significant event. Early 2012, we started two organizations, really to grow sustainability in Python. The thing that sort of kept me going for 20 years has been a real strong desire to see open source sustained. Everything most of the things I've been doing are really driven by that desire. Started a company. I'm really passionate about the business of open source. I think it's important that there are people doing market-related activities in open source. I'll talk about that a little later. So started a company, Anaconda, and we did 5 businesses basically, just trying to figure out something we could do that would sustain open source. We found, and 3 worked, and 1 has worked really, really well actually. So it's been exciting to see that happen. And then the other thing we started in 2012 was NumFOCUS. Who's heard of NumFOCUS? Raise your hand. Not very many. Okay, so everybody go look it up, understand what NumFOCUS is. That's your homework assignment through this day. NumFOCUS is the foundation that supports Pandas and NumPy and scikit-learn and Jupyter. It's the 501c3 foundation whose purpose is to sustain those organizations. So it fiscally sponsors those projects. It provides resources, developer sprints, sustainability projects, really important organization, something that it's right here in Texas, but people are all over the world who contribute to it. And we'll talk a little about the PyData community. Who's been to a PyData conference? Who's heard of a PyData conference? Let's generalize that. Okay, more of you have heard of PyData. If you haven't, another thing to be aware of. All right, let's just get a show of hands about, so the Python ecosystem is full of different kind of communities, right? Python's been growing. Many of us know that. We're all excited about that, right? The phenomenon has been interesting because every time you're on that knee of a curve, you think, wow, this just showed up out of nowhere. Of course, we know that's not true. There's a whole lot of history before that. And all of a sudden, things start growing, and it's been really happening. So who here uses Python, thinks of themselves as a developer, as a computer programmer developer? Okay, that's a pretty good group. That's usually in a Python-oriented event. That's what we'll see, maybe half. All right, who here thinks of themselves scientist, data scientist, quantitative, engineer? Okay, a few of my friends. All right, there we go. That's really where I'm coming from, although I've learned a whole lot of programming in the middle between that. That's kind of my background. I'm a scientist at heart. All right, who here is sort of a sysadmin, DevOps, IT, that sort of thing? All right, a few of the stalwarts, great. Way to identify, way to stand up, way to show forth. A lot of those folks are here as well. Now, who didn't raise their hand? Okay, now how do you consider yourself? Oh, who's an organizer, community organizer? Is that, maybe I'm missing folks. Why do people come to PyTexas? Awesome. Well, so there's a mix of folks, and actually Jake Vanderplas gave a wonderful keynote or a wonderful talk at the PyCon where he talked about the fact that Python is composed of lots of communities, lots of organizations, lots of people that come together. So it's extremely diverse in terms of different kind of backgrounds, different kinds of things people care about. So a lot of times you'll see packages in the Python ecosystem, you go, what in the heck is that? Why are people doing it that way? That seems so odd. And what I've learned over the years is when I have that instinct to think that is really odd, I go, okay, I don't know something. Let me back up. There's somebody out there doing some things maybe I don't know about, and it's an opportunity to learn. And every time I've taken that step, absolutely, it's been true. It's an opportunity to learn that somebody put some effort into doing something, because it's a lot of effort to release packages and put effort into doing that. There's a reason. And the Python community, the real strength of it, the real power of it, is the fact there's so many of us that come together to do disparate things. And then we can cooperate at the boundaries. And it creates a really powerful, rich ecosystem. What's been happening here is that Python's been growing. A big part of that growth in Python has been kind of the scientific stack over the past 5 years. And it's, it'd be interesting to see why, and many people are arguing about why. I attribute it to scikit-learn, pandas, and Jupyter. And then most recently to the advent of TensorFlow, Torch, and the machine learning explosion. Everybody's looking around going, AI, machine learning everywhere, I got to do this, knowing more about it, about the idea than the concepts and what we actually have to do to accomplish that. But still, it's everywhere as people are trying it out. How do you try it out? Well, it looks Python's the way to try this out, which is true. So it's been exploding in particular. So I come from the Python scientific stack. That's my home, that's my niche community in the ecosystem. I have been, I think, officially am, though maybe they've flipped off the bit now since it's been about 10 years since I've done anything meaningful, but I used to be a Python core developer. I interact with the core developers all the time, know them very, very well. The reason was for my contributions to help the Python scientific stack improve. Things inside of Python to make the scientific stack work better. It's actually a very valuable thing that there aren't enough of the folks like that. Aren't enough folks who do the scientific work, then flip over to interact with the more computer science world of the Python core dev team. But my heart is in with the Python scientific stack. But it starts with Python. And why Python? Lots of reasons why Python. Easy, it fits your brain, gets out of your way, you can think at a high level, you don't have to do pointer chasing. While I have programmed in C and Pascal and many other languages, and I can do that when I need to, I really do like to think at a higher level, and Python lets me do that. But on top of Python is this federation of other packages. Now what's interesting is none of these are really, they're all very different. Like each of these communities has a slightly different feel, take, NumPy and SciPy are quite connected, but Jupyter is its own world, Matplotlib, IPython, but there's this basic foundation of additional packages, and I've added NumPy and Dask to this list because this is one thing we've been working on for 6 years at Anaconda, is how do we scale this? How do we take this ecosystem that's amazing and make it work on GPUs and modern hardware and also make it work on parallel systems so that the Java world doesn't come back and bite us and force us all to program Java just because they have concurrency or claim they have concurrency, right? So that's been our work on Dask. Who's heard of Dask actually in the room? Anybody? If you haven't heard of Dask, okay, who's heard of Spark? Yeah, so bad Python people. Bad Python people. That many people who know Spark who don't know Dask. If you're one of those folks that knows Spark but doesn't know Dask, you have an additional homework assignment. You need to go figure out why in the world I would mention those two together in the same breath. Now, they're not equivalent, not exactly the same. You could use both of them together. But if you're a PySpark user, you should check out Dask and see if it does what you need it to do first. All right, so I'm not going to say much more about that, but there's plenty more to talk about. Okay, so then on top of that, you have other packages. You have Xarray. Pandas is the one a lot of people know about. Pandas has brought so many more people to the Python community. How many here first started to use Python because of Pandas? Only a couple, right? If I go to a PyData conference and ask that question, I get about half the room, right? It literally has attracted and brought so many people to the Python ecosystem because it's data munging, and helps you just get a handle of your data very quickly. It's got read CSV files. If you think of your data as a table with headers, you think of an Excel spreadsheet as your data, Pandas lets you read that, manipulate it, and munge it, do group bys, aggregations, simple, lots of important things. Huge library. Matplotlib, plotting. My dear friend John Hunter passed away in 2011 or 2012. Very, very sad, very, very sudden. But his project lives on, and it continues in the hands of lots of people, although not enough people. One of the challenges we'll see in all of this is sustainability, and how do we actually keep these projects going. So Matplotlib, and then Bokeh is an interactive visualization tool. SciPy is one we'll talk a little bit about because it reached 1.0 just a few weeks ago. That's really exciting, yes. I think we should definitely clap for that. And I'll tell a little bit of the story, at least from my perspective on that. It has 560 contributors, so there are 560 stories to tell around SciPy. But I'll tell a little bit of what my experience was. And then on top of that, you have additional libraries that do even more. You have scikit-learn, which is the venerable thing that's brought everybody to the table. Essentially, Python has become the de facto language of machine learning at Google, Microsoft, Facebook, all the big people, all the players are recognizing that. Like even Apple, right? Even though their machine learning story is Core ML, they're basically, how do I make models and convert them to iPhone? They basically want to have your models deployed on iPhones quickly. They have Python tools to do that, right? That's pretty impressive. That's pretty exciting that everybody understands that. So Python has definitely become the way to do machine learning, to do advanced statistics. Then finally, you get to, well, maybe not finally, and finally on top of this is actually applications. You get to sort of frameworks that are more industry specific, BioPython, AstroPy, SunPy. So AstroPy, SunPy, some of us think that Sun is a star, and it is. It's just close enough we can do more with it than what AstroPy thinks about. So I got a really great slide from the eclipse from one of my friends at NASA. Beautiful display of the corona, all this detail about the sun. A lot of interesting things you can do to study the sun, but then NumPy and DiPy and many more. Of course, and a lot of folks are interested in the TensorFlow, the Torch. Now, TensorFlow is a C++ library, but it has a really crummy Python interface. But fortunately, a very brilliant person created Keras, which is a much better Python interface to not only TensorFlow, but other things like Theano and other backends. So I do love the folks at Google, but I've seen a lot of interfaces from people that effectively, they come from Java, they come from C++, and they think that Python should be written the same way. And you know who I'm talking about because you've met some of them yourself. And there's definitely a Pythonic way to approach things. And it's not that we're elitist, it's just that look, the purpose of Python is to get out of your way and not inundate you with methods and class calls. And so write applications. I came to Python because it was easy to express, because I didn't have to basically write a whole bunch of classes and methods in order to do what I wanted to do. When you write APIs for people that are trying to use Python in a similar way, you have to think about the same way. However, some of you in here are developers, and you're going to write libraries for developers as well. Another important concept is that there are two different use cases. There are developers, and you write libraries for developers, and you write libraries for users, and they're not the same thing. And I learned that the hard way, actually. And you'll see many of the things I wrote as a young person, things like SciPy, a lot of the libraries, the interfaces in SciPy, things in NumPy. Really, they're kind of libraries and user interfaces and trying to do both. And sometimes when you try to do both, actually most of the time you try to do both, you stumble. So I'll talk a little bit about, I am from Anaconda. I founded Anaconda a few years ago. I talk about Anaconda. Essentially, its big value is it brings all this together. So I just talked about all this wonderful goodness, and there's 100,000 libraries on PyPI, and about 3,000 of them are useful to the scientific community. Getting all that stuff and configuring it. When we first started this 10 years ago, when I was releasing NumPy, people were so desperate to not have me change NumPy because they spent all day setting up their infrastructure on top. So they might have not all day, like all week. So they put NumPy in, SciPy, Matplotlib, and all these libraries, and they'd come back and say, no, you can't change anything about, if you change NumPy, you cannot break my ABI compatibility. I can't recompile everything. It'll be another week. So packaging was critically difficult. It's much different than packaging when you just have Python scripts. If you just have Python scripts, that's one level of packaging, and it's important. But the scientific community has a harder packaging problem because it's not just had Python scripts, it's had Fortran code and C code and libraries like TensorFlow and libraries like MinPack and Fortran that you have to also compile. You effectively have to create a systems packaging story. And that's one of the reasons we created Anaconda as a general purpose systems packaging story, particularly suited for the Python scientific stack, but it actually turns out to solve other problems as well. Now, my passion is data science, modeling, help people understand the world. I'm going to go quickly through this, but effectively this is modeled after how do I think about what the data science problem is, and how Anaconda fits into it. The goal is to take data and get decisions and actions. And there's this concept called data products that's emerging, which is effectively microservices, dashboards, REST APIs, new data sets, reports, applications, notebooks, everything that's derived from data that you're going to deliver to somebody else. And how do you get there? You want to understand the world, typically. You understand the world by understanding data first, and that's where most of the effort is, in fact. 80% of the effort is taking data and then understanding it, cleaning it, manipulating it, building a model, picking a model, so that you can use that model to actually produce something useful in the world. That data science workflow, it starts with data. And a lot of folks out there, it's kind of waning, fortunately, but there's still a lot of people out there who believe that the way to do data science is first take all your data and throw it in one big bucket, right? Who's heard of the data lake, right? Everyone like, get a data lake, that's the answer to everything. So data lakes are a nice caching story, right? It's like, sure, you want to do data close to each other for certain purposes, but effectively the internet's a data lake. I got URIs to everything. Like the problem is not that I can't access my data. The problem is what to do with it. The problem is I don't understand it. The problem is schemas. The problem is understanding where it is. It's the metadata. It's the virtual data lake. It's the data catalog. It's understanding what I can do with it that's most important. Interfacing to data, and we know that in the Python world because it's so easy to write different interfaces, even though it's a bit disparate. And I think there's some things we can do here to improve that. Right now, for example, you have to, before you do data science, you have to ask yourself, where's my data? I have to say, is it in a database? Is it on files? Is it in particular HDF or BZ3 or some other format? And the answer to that question changes the code you write. Right? It's a bit sad, actually. There isn't any way to sort of understand, here's my data, and then quickly get it to a pandas data frame or a NumPy array or an X array or some known set of key pieces. So we wrote Anaconda, created Anaconda. I like to think, the growth has been phenomenal and great. We think we have about 4.5 million users. We're not quite sure. We do know we have about 2.5 million downloads a month, however. We think it's correlated, correlation and causation, not the same thing, but depending on who you're talking to, you can sort of try to infer that we've had to help this process along. But I think it's a community process. We help each other, and it's all one group. Now at Anaconda, as I said, my passion has been to support more and more open source. We've had the privilege at Anaconda to produce a bunch of open source, actually, and a growing influence in open source. Starts with Conda and deployment reproducible data science, Conda and Conda build and the Conda story. Talk a little bit about that at the end. Who here has used Conda? Okay, about half the room. Usually at a Python-only conference, that's about what I get, because a lot of folks out there, they don't necessarily understand the difference. Conda was critical, essential to basically installing all these scientific stack. Now, it's starting to get better with just pip, but pip still hasn't solved some of the fundamental problems that Conda solved to enable this. And so it's kind of just a Band-Aid still in the pip world. And so I still, Conda is still the best way to use it. Conda is an open source, BSD licensed, completely free package manager solution that works across platforms and across languages. So we promote Conda to your whole data science stack. R, Python, if you're into Julia, you can use it too. Michael Sarahan's here. He's actually on the team that produces Conda. I'll talk a little bit more about how Conda came to be. In 2012, the story I'll tell is I went to our very first PyData was at the Googleplex. Guido was there, Wes was there, I was there, Fernando Perez was there, and we sort of were just lamenting, here's this great stack, we see the power, but packaging sucks, right? We just can't get everything installed. And so I asked Guido, I said, Guido, what do we do? Help me out. How do we fix this? And he said, you fix it yourself. We're not going to do it. Okay, we'll do it. We'll do what we can to fix it ourselves, and that's where Conda came from. It came from a desire to fix the problems that the Python community wasn't going to or be able to fix. Now, since that time, the PyPA, Nick Coughlin, many other folks in the Python world have done it's improved. Things improved significantly. But this is why Conda exists. It existed before any of that stuff started to come around, and it still solves problems differently and in my view better than pip alone. Now Conda and pip work together. They're not competitors at this point. Conda you can think of more like Yum or apt or your system package manager, and then you can use pip on top of it as well. So I say that just because you're going to find people using Conda, because it's, like I said, 4.5 million people are using Anaconda out there, and you're going to find them, and you need to understand why they're there. And you sort of think of them as, oh, I see, this is, instead of having to deal with Brew and Yum and apt-get and Chocolatey and NuGet and a bunch of other package managers on every different system, I can just deal with Conda, and then pip on top works just fine. And we're making strides in this next year to even improve some of those. If there are any little niggling issues, we'll improve them. So that's the foundation. That's actually the foundation that Anaconda has kind of become very focused on. We have more people there working on this problem than anything else. But we also have a bunch of other, we sort of did a lot of other explorations. One of my passions has been scaling the Python ecosystem, the PyData ecosystem. And so we produced NumPy and Dask. And those were funded by DARPA initially, and now they're funded by projects and people and other customers. And I won't be able to talk about those. Those are really cool projects, though. So if you get a chance to look them online or hear somebody else talk about them, please do. I won't be able to talk about the visualization that we do, which is really cool. Bokeh and Data Shader and HoloViews. And we do some really, really cool visualizations on top of Python that really are incomparable to other things you'll see out there. We support Jupyter Lab. How many heard of Jupyter? Next generation of Jupyter is Jupyter Lab. Jupyter Lab is an emerging project. Should be coming out in beta probably first of the year. I'll be looking for it next year to be exploding in usage and popularity. So it's early. You can try it. It works today. It works pretty well today, actually, especially if you're just going to use it. If you're going to build on it, you might want to dig a little deeper. You can wait a few months, and you'll probably be a little bit off if you're going to build extensions on top of it. And then data virtualization access is very new stuff that we're working on. So, I have a bunch of slides on Conda here. Just didn't know Michael would be here, but I thought I better include them just in case. So I talked about this. I'll go fairly quickly. The big thing is it helps this virtual environment notion, which came from Python, a beautiful idea, and Conda takes it to the next level and how system environments, basically, where all the shared libraries are linked only locally, everything's self-contained. So many people turn to Docker when they say, I got a bunch of packages that have to be written together, I have to use Docker. And you can use Docker, but it's kind of like a big sledgehammer when all you need is a little tiny hammer to hammer a picture up. And if you're taking sledgehammers all the time, you can do it. You have to be very delicate, and it's really heavy. Conda are kind of lightweight VMs. We think of it that way, lightweight software-defined VMs. And you can have thousands of them on a system and lots of installations, all so workflow specific. You have a script, has a bunch of dependencies. Conda can define those, install it separately, and off you go. reproducible work, reproducible data science easily. So I'm going to, invite you to look this up so we can talk about a few more things before I have to get off the stage. Actually, how much time do I have? What's the, who can help me there? What's my end date? What's that? 10:10. I've got, so 20 more minutes with questions. I'll leave some time for questions. I think that'll be fun. So I want to spend some time talking about communities and how you build more of this. Effectively, I've just shown you a bunch of stuff I've had the privilege to be a part of. Sometimes I tell people that the most important thing for your data is to get the best tools on your data. So please take a look at what me and 1,000 of my closest friends have produced to help your data. Now, what I'd like to communicate today is give you a little story about that and hopefully inspire some of you to see how you can take 1,000 of your closest friends and produce something amazing for the world, which is still possible. There's so much to do, so much possible that can happen. So my story really starts with science. I was a student and I loved the idea of doing science. I thought I'd be working MRIs, I thought I'd be doing ultrasound, but effectively I got distracted during my PhD working on other stuff. And that other stuff kind of ended up leading to more of what I was doing. So I started as a scientist. I was doing satellite remote scatterometry, figuring out data from satellites. It's actually a scatterometer. You send a pulse of electromagnetic radiation down to the Earth. It scatters back to a satellite. Kind of pretty weak by that time, but you can still pick it up. And then looking at that, you could actually see, how the waves on the ocean particularly, it'll scatter differently based on how the wind's blowing. So just looking at the backscatter from the oceans of the Earth, you can infer what the wind is, what the wind speed across the entire Earth. So I was doing that back in '96. A lot of fun, tape drives, VAX systems, Perl scripts, a whole bunch of crummy work now, actually. I think, man, my life would have been so much easier today. Could write in a couple of scripts. So I kind of got into that story of like high-level development, script interfaces to scientific computing. I ended up at Mayo Clinic where I was instead studying MRI and ultrasound, and I really enjoyed it. I ended up doing a lot of image processing, four-dimensional data sets, trying to take derivatives of those data sets. We were trying to solve a problem. Elastography had just come out. A colleague of mine, Raja Muthapilia, had published a paper in Science. Really cool paper because he was basically showing wave propagation in people. You could essentially attach a speaker to somebody in 400 hertz to 1,000 hertz, so audio sound range, but a little bit higher vibration. And that buzz would cause waves to propagate through the body. And with MRI and ultrasound, turned out, I did some ultrasound work on this too, you could actually visualize the wave propagating through the body. So you could take time snapshots in time. This experiment had to be set up right. You had to do some special things with the gradients, but you could basically pick up and see an image like you're seeing on the screen here of waves propagating. It would be a movie, actually. You could play it and you watch the wave propagate. The idea was from that, we ought to be able to see how stiff things are. Because waves, the wavelength would be longer when it's hard and softer when longer when it's hard and softer and shorter when it's soft. So by measuring wavelength, we figured that out. So I got into, how do I do this? How do we do inverse scattering, basically, but when I measure inside the field? So that's why I started using Python. I was using MATLAB, and it turned out it was blowing up my memory because I had these 5-dimensional data sets and it was blowing up my memory. I thought, well, if I could just do it with float 32 instead of float 64, I'd save half my memory. I'd still be able to do this interactively. And MATLAB didn't do it, but Python, I looked around, wow, this Python thing with this numeric array object has a float 32. Let me try it. And I found that I really just love the syntax, and that kind of started me off on my journey. So I started using Python on 1.4, right? Anybody here use Python 1? Anybody? Any Python 1? Thank you. All right, we got somebody. 1.5, excellent, yes. So pretty quickly, I started using Python in 1997. Right, on 1.4, which was fun. And it hasn't, things have changed for sure, but effectively the C code is very similar. The structure of how it's put together is very similar. And I met Guido back then. I went to an early PyCon, and I really fell in love with both the language, the syntax, and then the community, the people that surrounded it. You go to the mailing list, you listen to people who are pretty generally sincere to each other and kind of help new people, and dumb questions that I would ask weren't treated with contempt. It was basically, oh, sure, yeah, here's a place to look. And then what I found is I could go out on the internet and I could find examples, right? And I like to put this example because I don't think he even knows this. Michael Miller is at UNSC, at Illinois. He was the one that got me started on my quest, basically. It was the fact that he released his package called Table.io. And it was just a piece of software I could go on the internet and download. And I was, the early days of the internet, that's how we didn't have Facebook, we didn't have Instagram, we just had web pages and IRC and email, right? That's how we connected. But we still formed communities, and we also still lurked. And I went and grabbed his software, he didn't really know it. Grabbed it and I looked at it, read it, said, oh, this makes sense how you do an extension. How do I take Python and extend it with C code? And so that, April 98 when I did that, and I released something called NumPy.io. NumPy name was actually in use back then. It was not, the module was called numeric, but it was called NumPy for short, numerical Python. And so I released a module called NumPy.io in June 1998, just its own extension module. And that and I did it based on Guido's May 1998 publication. So this is a slide to really encourage you that, you might have a module out there, you don't think it's a big deal, but if somebody's using it, somebody's reading it, or if you have an essay you published that helps just explain how things work, it's a big deal. It's what makes the community of Python sustainable, powerful. You never know what's going to happen with that. This started me on my journey, effectively. So I released NumPy.io, and then I kind of got really hooked with the idea of releasing extension modules on the internet and having people use them and getting feedback, and that kind of led me over a cliff. From which I'm still recovering. So it's been a long journey, but it's been an exciting one and really, really fun to watch all this happen. So early pieces of SciPy started really back then in 1998 with NumPy.io. That became some of those modules, some of that code is still there in SciPy.io. Basically, that's the remnants. That's where you see it. It became a part of that. CFE's module in November 1998. This was all the area. So I was a math geek, right? And I loved Bessel functions and area functions. I loved differential equations. So I said, wow, Python needs access to some of these cool special functions that we need. So I went around, I'm not going to write them all, but I went around and found CFE's module, which is C code. CFE's is a C code that implements them. And I just wrote an extension module, linked them all, and make them something called NumPy ufuncs. It sort of started me on my journey to be passionate about how ufuncs work in NumPy. There's only like 4 of us in the world, so be nice to the other folks you find that know about NumPy ufuncs and how they exactly work. FFT wrappers started collaborating. Gary Stringman, actually, he had something called stats.py that I pulled together, and this sort of started the idea of, hey, here's a couple of modules. There was an early mailing list discussion. Lots of people saying, if we just had optimizations, linear algebra, we could really start have something here. It could be used for a lot of people. So I went back once and looked at the mailing list in 1999 and kind of see, this is sort of the genesis of SciPy. During that time, in December of 98, basically, I was this PhD student, so I had more time than sense. And I said, I can just start working on this, right? This will be good. I need it I justified I kind of need it for my PhD thesis because I need to do some simulations, ordinary differential equation simulation, need to do some plotting. So sure, this is right in line. Didn't really tell my advisor because he would have probably said, no, that's not going to help you. It didn't really. It just delayed my PhD by about a year. But it was a lot of fun, and it certainly helped my career. And basically, I went back and through 1999, you see, hey, here's CFEs, here's SigTools, here's Multipack, here's a lot of things were happening. Fortunately, a gentleman named P.R. Peterson rescued me from my insanity and said, you're doing this all manually. Why don't we just write a module to automatically convert from Fortran to Python? Why don't we use these automatic tools? And F2Py emerged in January in 2000. So a lot of times, just being active and doing your best, putting things out there and accepting feedback, really what starts people collaborating together. One of the things I find lots of people are kind of nervous. They're scared to put their stuff out there. And it's true, it's a very exposing thing, right? Because I guarantee people are smarter than you out there. I guarantee people are smarter than me out there. There's still lots of people smarter than me. You put something out there, somebody's going to look at it and go, yeah, this isn't great. Awesome. So how can I make it better? Right? You're not going to get better unless you get that kind of feedback. So that's how SciPy got started. And all the people I've met over the past 20 years have been basically my internet friends. Right? We've got together because of those me putting information out there and just saying, hey, take a look, get feedback, and then have conversations. So in 2001, Eric Jones added a few packages, Weave, Gluster, and P.R. Peterson with F2Py and Interpolate and helping with linear algebra. We pulled all that together and released SciPy in 2001, the very first 0.1 version. And most of the effort was packaging. Most of the effort was chasing down bugs in compilers and making sure your Windows binary download could work. Because what I found early on is multipack was the very first kind of congregation of these things. And multipack was downloaded a tiny bit by Unix folks until Robert Kern made a Windows installer for it. And then when he made a Windows installer for it, I saw that there were 10x number of people that used it. So just making Windows, that sort of convinced me that Windows installers, even though I wasn't a big Windows fan, it convinced me I got to make Windows installers, right? And that's sort of been a necessary, I like the Windows platform now. They've actually come a long way, but early on, it was a lot of work. So, that was SciPy, and that's really what got me started. Now, along the way, as I was doing SciPy, of course, then you're exposing things about the underlying array object and going, okay, there's some things here that aren't working. And that's what happens anytime you dig into a code base. I guarantee if you start working on a code base, you're going to find things you'd like to improve about it. I hope you do. If you haven't, then I don't think you're looking hard enough. Right? Because I guarantee none of us have reached that Shangri-La of perfect code, where everything's exactly as it would have been had I looked at it 20 years in the future and looked back at it. Like, it just doesn't, this is not how it happens. So you're gonna find issues, and you're gonna find challenges and opportunities. Those are opportunities. They're opportunities to collaborate with your friends, collaborate with your not-so-friends, collaborate with your people who are going to be friends, once you get over some of the interpersonal issues you might have with them. All of that's possible, and all that will happen if you make things happen. So, NumPy came out in 2005, and become very, very popular, but it didn't come out alone. It didn't come out because I just flew out of my head. It came out because of the work of Jim Fulton in 1994 wrote a matrix object, and that inspired Jim Huguenin to produce numeric as a grad student at MIT, and that's the package that I saw and the code base that I saw, and then the problems with it. The fact that they wanted to have more types, they wanted a memory map to larger data sets, that inspired Perry Greenfield, and we talked in 2001, and they wrote NumArray. And the fact that SciPy was my baby on top of numeric, and then lots of people were starting to write modules like NDImage and other scientific modules on top of NumArray. I went, oh my goodness, we have this forking of containers that's causing siloization of libraries and decreasing the collaboration potential. So I felt duty-bound to write NumPy. It's really the only way I can describe it. It wasn't something I pined to do, wasn't something I thought I could do, wasn't something I thought I was even qualified to do, to be honest. But I felt like, I've got to do it. I think I know enough. I can work hard and try it. I got with as many people as I could, and we worked hard and produced NumPy. And it's been very, very successful at kind of connecting people together. If you'd like to talk to me later, I have ideas about how we can connect the fracturing world of Java and R and Python and Julia together, actually, too. So that's my next big idea. I'm older now and have less time, and my family needs more money from me, so I can't just not work and just work on that. But I have good ideas, I think, if you'd like to talk. It'd be fun. But today, those efforts that started with me would not have survived had it not been the other people that actually made this work. These are impressive community efforts. There's 500, I just updated this today, 553 contributors according to GitHub on SciPy, 576 contributors on NumPy according to GitHub. It's amazing to watch, actually, and it's these folks who actually allowed SciPy 1.0 to come to pass. So I stopped being able to contribute to SciPy even though I started in 1998 and was passionate about it for 12, 13 years. In 2010, I had a job. I had my, I could get by on $18,000 a year when I was a graduate student and only had 3 kids at home, and they were all young. But by the time in 2010, I have 6 kids at home. They're starting to think about college, and I'm thinking, I got to make money now. I got to have a real job. So that turns out takes your time, and most of us understand that. Most of y'all understood that when you're younger, unlike me. I had to figure that out a little bit later. So I had to stop working on it about 2010. Cheerlead from the side, be really enthusiastic about it. Other projects who kind of had, NumPy was certainly taking more time. But since then, they moved to GitHub. And I think the contributors before GitHub was something like 20, 25, maybe into the 30s. Because to contribute, you had to say pat, you had to use the patch command, send a tarball to somebody, stick it somewhere in an FTP site. It's a lot harder. So it was harder to get contributors. Python 3 support, then basically a slow move. Eventually, Polly Vertanen, Ralph Gomers emerged as kind of leaders of the SciPy community based on their contributions and their involvement, and they were able to move it towards SciPy 1.0, which came out just this year, and I was so thrilled with the work. So I don't know if I have all the keys to success. I've tried to share just a little bit of kind of my journey and story, but there are some things that emerge. And if you're kind of curious about how does one create this kind of help create this kind of activity, give rise to this kind of activity? What are the keys? So I would say it's actually a lot of hard work, and it's very persistent. You have to have a vision. You have to believe in what you're doing, because nobody else is going to, for at least the first 3 or 4 years, really, until you have something that people can use. It's going to take time. So many people, I find it's interesting. I meet people and they say, my project, it's started and nobody's using it. Well, how long did you put it out there? 3 months ago. What? I mean, people have barely had time to register that you exist for 3 months. I mean, come back when it's out there for 18 months and you're having struggle with adoption, right? You know, it's a curve, and it takes time. We're all humans. Just think about your own attention span, your own ability to understand and process new information. I just showed you a bunch of stuff today on a technology slide you hadn't heard of, right? But you should have. It's really cool stuff, and you're not alone. There's a lot of cool stuff out there that none of us have heard of that we all have to individually try to figure out, and that takes time. And it takes word of mouth, takes conversations, and it has to be good. So even if it's good, it's going to take that time. So the biggest thing is to try to get feedback. I have a colleague, Matt Rockland, who's excellent at this, and he really, really strives to get early feedback, and you have to be intentional about that. Basically, go ask your friends, go try this out, give me feedback, and be open to accepting the feedback that's there. Others need proof to jump in and doing what you're doing. I think do what is right, not what is convenient. So often it's a very difficult challenge because you're effectively living your life in iterative mode, and you basically have a local optimum you can solve for. I got to do things that I got to have enough money, got to please my friends, I got relationships I don't want to kill, so I need to do those things. And somewhere in that space, you have to decide what's right for you. Right? What does right mean? And it's a gut feel. It's kind of built on your values, on your previous decisions, on the friends and the things you want to do in your life. But you'll definitely know. You'll think, well, this is convenient, but this is right. Shy away from the convenient, lean towards what you think is right, and it'll be recognized. Timing's everything. Timing is everything. Sometimes it's just that the things come together. And so I've always found it convenient to look around at other voices, get other feedback, get other people, get input from others. Because alone, I see less than when I'm with a group. I love this quote from the good you do today will often be forgotten. Do good anyway. Very important to realize that you won't get credit for everything, and that's okay. In fact, the more others get credit for it, the more they're going to be enthusiastic about joining and supporting, and the better off everybody's going to be. So share credit, give it away. Try not to. Whenever I've tried to show, my goal with credit is actually to point directions. I want to help. I want to help steer people to improve things in the world. Give the best you have. It'll never be enough. Give your best anyway. You have to build a community. And I'll have more on that, just a couple of slides here. One of the things I'll just point out here is you're going to have to listen to others. It's going to require sacrificing some of your ego. We all have it. You have to have an ego to put something out there a little bit, but you're going to have to recognize that someone will point out that you suck in some particular way. And don't worry about it, you do. It's okay, they do too. So the point is, you just get that feedback and just see what you can correct. Some of it is actually you don't. It's just a difference of perspective. You have to understand the difference between yes, okay, this is the thing I can fix. That's just we see the world differently, and those are to be able to tease out. I think you have to treat other people like they matter to you, and to really treat people like they matter to you, they actually have to matter to you, and that means you're going to expose yourself and you're going to get hurt. I don't see any other way around that, right? The other way around that is just contain yourself. I'm not going to expose myself. I'm going to only shield myself. You have to treat people like they matter and really feel like they matter. And then, yeah, they might hurt you. Do it anyway. Patience and luck and some timing. One of the things I wanted to point out, and some people have seen these slides before, cultivating a community starts with a small group. Right? You don't come out there and, 20 of us had this idea. I guarantee 20 of you didn't have an idea. You had 20 ideas, right? Or at least 10, maybe sharded. It's actually a physiological problem. Someday we'll know much more about the brain, and we'll see how what we know about the brain actually maps to social engineering, to how our groups and how we organize together in software groups. And one of the things that's very true is we can only have, there's a really good study of cell phone data that talks about Dunbar's numbers. And one of the key Dunbar numbers is 5. that range 3 to 5. That's basically the number of people you can be BFFs with, best friends with. You can't have really more than that as a tight group. And that's really important when you're building something. Have a small group that you can, each of you, have a relationship with the other and model each other sufficiently in your head to have tight and intimate relationships to know something. So it does start with one. And you look out there at the projects, any of the projects that are out there today effectively have small numbers of contributors early. Right, and I've just showed you SciPy, and it has 576 contributors, but they didn't all immediately show up and start coding. There's a small group. And in SciPy, it's interesting because I was very heavily involved early. And what you saw is around 2007, I was over on NumPy, and then basically SciPy needed somebody else to be contributing, and so Polly and Rolf, you see them starting to contribute. You see the sort of handoff of contribution. That's the way it always works. So one person may start it, but to really get it going, you have to have lots of people involved. And that's the key next step, is how do I go from that small group of 3 to the larger group of 10, to the bigger group of 15, to the larger group of 100. Each of those steps requires effort and interaction challenges. And there's no sort of magic bullet. A lot of it is hard work, and hard work cultivating people. So Conda, for example, at this point, 2016, this a community package building community called Conda Forge, and 600 people are now writing Conda recipes instead of just the 2 or 3 that were at Anaconda early. 600 people writing recipes caused us to change the way we do Anaconda, right? To basically adapt to this community of people. It's an exciting thing to see. I just have a few more slides about cultivating community that I'd like to get across, because one thing I love about Python is the community. People say they came for the code and stayed for the community, came for the language, stayed for the community. And people take it seriously, and you look, there's codes of conduct. This PyTexas has a code of conduct, and they try to make them simple, but they just try to hit the foundational key points. This is Python's code of conduct. A member of the Python community is open, considerate, respectful. You can imagine a number of other attributes you could apply to that, but you can kind of get the general feel of what this means. We're going to share our ideas. We're going to be considerate of other people's ideas. We're going to be respectful of other people's views. In an ecosystem like Python, you're going to find a lot of views, and people are going to think differently than you, and that's okay. In fact, that's valuable, because diversity is the mix. Having diverse views, having diverse people, having diverse backgrounds is important to bring the best ideas forward. Inclusion, though, is diversity at work. I mean, we can have diversity, but everyone's segmented. Diversity, but we're diverse, but nobody's talking to each other because we're all over here, because only the people that know each other talk to each other. And that's hard work. It's work. It's uncomfortable work, but it's important. There's a couple of, I kind of traversed the different ecosystems of the world. I was looking at different societies and looking for words that cultivate community in each of those societies, because they're human properties, and every single ecosystem, every single set of humans have developed the same set, actually. So I'm a student of religion. I know religion isn't something a lot of people are into, but I would invite you to look at the world's religious cultures, because they're examples of communities. There's examples of how people organize them with each other. So even if you don't believe in their tenets, every one of them has sort of to stay together, to stay cohesive, there has to be community principles involved. And it can be very enlightening when you do that. So one of the community principles, I think, is this idea of philia. This is sisterly or brotherly love. It's the idea that you'll do well by someone for their own sake, out of concern for them, not a concern for you. Kant talked about the moral imperative. Other people are ends in their own, not just means. So this is an important concept. The Sanskrit word for selfless sacrifice is seva. Right? This is another concept. In order to build a community, you have to have people who are sacrificing for others, recognizing that their own what they can do for others actually defines themselves. And it's actually a natural impulse that all of us have. We're wired into it. Fortunately, that's how we've actually been able to grow and thrive as society and civilization. Arabic has a word for trust. Actually, look in Arabic, and I don't read Arabic, but as I found this word thika, like all the businesses have this word in them, thika. It's about trust. I love this quote from Charlie Munger. It's basically, and I've seen this in action, and as you get to larger scales, I think Dunbar's numbers prevents this from really operating at huge scales. I think then you have to talk about APIs. But in the smaller work group efforts, it's about this web of trust. We don't work together because we have policies and procedures that we follow. My close colleagues, my family, the people I've built software with, it's not that we had all these procedures we followed in order to interact with each other. So we trusted each other, and we worked together in order to accomplish something that none of us could do alone. And And then the last thing I like to talk about is sustainability. One of the reasons I've been focused on the business of open source for the past 10 years, I left academia because I recognized that I valued enabling business to support open source more than just writing papers about it in academia. Even though that's a very valuable thing. And those in academia, I really respect the teaching and the work that goes on there. I did a lot of work as an academic too. I love that profession. But I found that for me, I was very, very enthusiastic about what I learned as I tried to figure out how am I going to make money off this free software. You can imagine I'm giving away code. I come home, my wife says, hey, how's the PhD going? Are we going to get out of school soon? Got the 3 kids, what are we going to do here? And I'm like, oh yeah, we're going to be out of school real soon, just as soon as I get SciPy out the door. And then my thesis. And I started to read books, actually, at the time. I wanted to read about economics. I wanted to understand, well, how's this going to work? It's a hard problem. There are a lot of really smart people much smarter than me thinking about this, but some of the things I've realized is that the strength and the power of any ecosystem is the entrepreneurial effort of individuals. People out there trying to do something for others and share it with others and voluntarily allowing them to share back with them. I see open source as really part of the same volunteer movement that markets are a part of. That's my view. I know it's not shared by everybody, but for me, free trade and the business of open source is part and parcel and critical to the success of open source. So I believe in the business of open source, and I try to figure out how to create sustainability through those mechanisms. One of the successful things we've done is the PyData ecosystem. So PyData now has 72 meetups throughout the world. They did 21 conferences throughout the world last year. They started with that one Googleplex meeting I talked about earlier with Guido and Wes and me and Peter Wang and Fernando Perez. And now there's all over the world and they're exploding. And the NumFOCUS Foundation has benefits from those the PyData conferences. It's one of the principal ways NumFOCUS got off the ground was PyData sponsorships and PyData funding. So my last slide, a couple of slides about you. And for me, the SciPy effort and the community effort has actually allowed me to explore this concept called Ikigai. This is a reason for being. It's a Japanese word that means this, and it's a nice intersection of 4 concepts. What do I love? What am I good at? What the world needs? And what can I be paid for? Right? If you can find those 4 circles in the intersection of them, in Japanese they call that Ikigai, and that's like a fulfilled life, a reason for being. It seems like I could get the what I love, what I'm good at. Those are usually pretty good, right? Connecting it to what the world needs sometimes means giving up a few things. That's kind of mission. And then my effort over the past 20 years has really been trying to figure out how am I going to get paid for this? And some of you are probably in the same boat. But there are ways, there are mechanisms. The world definitely needs it now. They need it more than ever. And your Python skills are definitely in that category with the growth in all the different enterprises. So recognize you can be paid for it today. And therefore, you definitely can connect all of these dots. So what will you do today to find your Ikigai? Thanks for allowing me to come, and I'll take questions.
So a recent blog post titled "A Plea for Sustainability in the SciPy Ecosystem" draws some questions to surface around the end of life of Python 2 and reproducibility of scientific results. What are your thoughts, and what might a place with Continuum Anaconda be in that?
That's a great question. Yeah, he wasn't my straight man, by the way, but his question was about there's recent blog posts, and there was a blog post by Conrad Hinson, who's one of the names I mentioned as early on, as someone I admire, someone who's very early on in the ecosystem, talked about sustainability. And how do we do this, and what are the approaches we can take, and does Anaconda or Conda have something to do with it? So I think the sustainability problem is a problem that a lot of people have to participate in. I think yes, Anaconda has something to do with it. I think NumFOCUS has a lot to do with it as well. I'm thinking deeply about how do we set up in structures so incentives are aligned so that those who benefit from these tools end up contributing back to the tools, right? And there's a lot of mechanisms to do that. One of them that I've thought about is like a sustainability badge or like a green label. Effectively, I think it starts with developers. I think that's the ultimate strength we have, is to essentially empower developers and people doing the work to demand it of their employers. Effectively, just like we demand green labels, we demand people to be organic farming or to do things to help the world. You basically have to, as a developer, ask your employer, how do we contribute to open source? We're using a lot of these tools. How are we contributing back? And kind of And I'm looking at like NumFOCUS maybe create a sustainability badge that you have, and then you can advertise you have. And if you're a developer, you look for that before you get employed. Like that's one mechanism I think that can help. It's really hard. It's a tragedy of the commons. It's a common known externality problem that economists speak of. But if you look into biological systems and how do they solve it, usually it's some sense of exclusion. It's some sense of like how does a cell work on the problem of externalities? Well, basically, if somebody's not contributing, they kind of use banishment. You know, if something looks like it's a parasite and it's taking from the system and not giving back, then kind of people organize to kind of ostracize and let it do its thing, but over there, away from us. And there are examples in Japanese culture about how they share water, and usually it has to do with community. Usually it has to do with shared mental models, shared worldviews, shared perspectives about what's about fairness. I think there's some things we can do there. I think there's more businesses that can exist. I think there's, go out and create something on these tools. To me, I think that's probably the strongest thing that I could encourage people to do. There are people here who have ideas of something you can do in the world. Create a business, create something you're selling, go make a bunch of money on top of these tools, and then give back. Give to NumFOCUS, sustain, and there's infrastructure set up. Give back to the folks that are making it happen. So it's a great question. I think NumFOCUS needs to help these projects as I've created a company and we've done product development, there's more than just the software that has to be created. There's product marketing, there's Q&A, there's project management, there's testing. A lot of these things that companies have to put in place to create software that people will continue to buy. In the scientific ecosystem, we have a lot of great tools out there, but they little rough edges. You update the version, broke your code. Right, and so I think there's opportunities for tools to determine that, tools to help people be aware of that. There's opportunities for people to provide services to help them update that. So I think we're just getting started, fortunately. But there are a lot of opportunities. Yeah, thanks. Long answer. Good question.
If I could add just a bit, a lot of the concern there with maintainability over time is making sure that old stuff works, and people have the unreasonable expectation that you should be able to use your old code with all the new versions of everything else coming out. That's totally unreasonable. So what Kona can help you do is reproduce the original environment that made things work and keep things working over time. So it's just very analogous to like hardware changing over time. You can't go and run an old VAX program without a VAX. That situation's getting better because software is the hardware is staying the same now, and you need to be able to reproduce the software environment.
Yeah, I think it's definitely a good point. Things are going to have to migrate, but being able to help people reproduce what existed before so they can run what worked before. And then also, I think giving people the transition, like the information about what's changed. That's an important thing that is often lost. So people don't even know. So I think even just helping people aware of their technical debt, the fact that, these things are using the interface have moved on past them in the latest releases. So you can't just go update and your stuff is going to work. So it's information flow, it's ability for reproducibility. I think Anaconda is a company that will support you, but it costs money, right? The cutting edge, our kind of philosophy is the cutting edge is free. You want support for old stuff. You're gonna have to pay someone to maintain it. Yeah, Jacob.
You showed some graphs about how fast Python is progressing and how fast your tools are developing. And you now can report that for about 2 decades of work, approximately, things are still going fast.
Mm-hmm.
Compared to things that happened in the past, about 5 years is a generation in software.
Mm.
You actually been going fast several years and continue going fast. Do you think this trend will continue? How do you see things about the future? Like 10 years from now, will things still be exponential?
Yeah, I don't know. Good question. Prognosticate about the future. I can do that as well as anybody can, and be just as bad at it, just as bad as my results. Great question. I think a couple of things. Things don't change as fast as you think they will. Like 10 years from now, I guarantee Python will still be around, and Python 2 will still be around. Actually, I hope 10 years from now nobody's actually using it for new projects, but there'll be people still running things in production that require Python 2. I guarantee that. I think what we'll see is, certainly the machine learning world will change how people program. A lot of things people do today with a program, they'll do instead by training a net or training some machine learning tool. I think there'll be a lot more of that kind of programmer. I think there's going to be a challenge because there's going to be a gap of understanding of how it works. there is a gap already between people that program like Python and understand, how it actually is structured all the way to the bit level. You'll have that as well in the machine learning story. So there'll be a lot of new people, and a lot of talking past each other, and a lot of opportunity for coalition building. So I see a diversity actually emerging in how people program in those programming communities. I see Python around, and I see probably we'll start to see another language within 10 years also start to gain traction, is my guess. And so it'll be interesting to see what that might look like and what that will be. Yeah, way back in the back, sorry.
You mentioned in the very beginning more less about community, but the Docker versus the Anaconda VM analogy. Are the VMs that you create with Conda shareable? Do you have the ability to zip that up or use it, or
Yeah.
send it to somebody else?
Yeah, there's a bunch of approaches to that. So they're not really VMs. They're sort of a Conda environment is a directory, right? And so you can zip that directory and hand it to somebody. It's not always the best approach, but one of the approaches is to create a tarball. Actually, Michael Sarahan's right here. He's the author of Conda Build, and could probably give you all kinds of approaches to do that effectively.
Yeah, it was mostly just a shareable development environment in Conda, right? Something that
Like a
multiple contributors to that, how you install the packages, maybe some scripts, and things like that. That can be pushed out to other.
What you share is less the artifact, the collection of bits, and it's more the spec of what Conda should install to create something equivalent.
Yeah, correct. You share the spec, and then you have an artifact repository where the information is obtained. And you can ship around a tarball if you like. Most people, that's the spec, and here's this artifact repository. Right there in the middle. Do you have your questions still?
Yeah, so I'm pretty new to Python, and before I came in, I knew about that Python had this huge, awesome community around science, right? Data science, and it's, I think for a lot of us, that's what we know about it. I think a lot of people think it's because
That's how you learned it, yep.
Are there other, I know there's general purpose and stuff that you can do, stuff, but are there other communities out there that are, that you see as sort of coming together and being as exciting and motivated to
Oh, yeah.
models rather than science?
Yeah, no, I think your colleagues here, you'll find many people who are basically motivated by things other than science. That's why they're here in Python. I think Django is one. There's sort of, beyond Django, there's a whole web ecosystem. So, because before that was CherryPy and there's Tornado. There's a whole asynchronous programming that's emerging. There's system folks that use, so all that, like Red Hat uses Python for a system level, so does a lot of other operating systems. They use it as basically script, better bash. And there's that whole world out there that has things on top of that. I'm less familiar about those folks. I know the Python core devs, kind of the tool folks, then a few of the web people, and then there's system people, there's sort of system work. But it's a good question. One of the things I always loved about Python is as a scientist, I knew there were basic computer scientists who had my back, right? And I didn't have to, I wouldn't, so the R community is a counterexample, basically. We have the R community, bunch of users. Now the language authors of R is a tiny group, actually, and it's sort of not growing. There's sort of one or two people there who, the bus factor there is a lot smaller. And I've talked to those folks individually. In fact, 7 years ago, a couple of them came to me and said, hey, can we just move our stuff to Python? Maybe we should write an R implementation in Python. Because they're basically seeing how we're going to sustain this. Now, a few more people have added that community since, but it's a very different topology and structure.
The reason I'm asking is that this whole model that you guys I'm noticing that you're right, community is really awesome. I'm interested in community civic engagement.
Okay.
Things like that. And
There's a whole data world. There's a whole actually social good, Python for social good. There's actually a number of those groups. There's a whole diversity. Women who code and PyLadies. Less advantaged groups like teaching computer programming. I think there's a whole other group like that. People how to teach programming generally, and Python as the entry point, like around the Raspberry Pi. talk with other folks here. I think there's a bunch of them. It's a good question. All right, thanks.